Hey, Velocity, want an apple?
Ouch! Why'd you do that, Herc?
Hey, don't blame me. Blame gravity. You know, Isaac Newton discovered the laws of gravity because of a falling apple.
Well, you're not Isaac Newton. Gravity did not throw that apple. You did.
Ah, yes, but if it were not for gravity, the apple would not have hit you.
Don't try to weasel out of it by using physics. Gravity or not, you threw the apple.
How do you know? You were looking through the telescope. Maybe Laika threw it.
Laika did not throw it. Laika's a good dog. You're a bad boy.
Well, I just wanted to start a discussion about Isaac Newton. The story is he saw an apple fall from a tree. Some say it fell on his head. He started thinking about it, and from there developed the laws that explain the planets' orbits and gravity. Let's Explore Astronomy is sponsored in part by You remember how we pretended to be astronomers back in the Middle Ages discussing Copernicus and then Kepler?
That was fun.
Let's do the same thing, but now it's 1687, and the laws of Newton are just coming to light. I just read this new book, Philosophia Naturalis Principia Mathematica, by this scientist named Isaac Newton.
Oh, I heard of that. That book explains how the planets move around the sun and how forces work.
Yes, it is quite fascinating. Newton says that there is a force called gravity that pulls everything. But there is also forces that can counteract gravity.
Pray tell.
Newton presents three main laws of motion that he says are universal, meaning they are the same everywhere in the universe. His first law says that if an object is at rest and not moving, it will remain at rest unless some other force causes it to move. So, for instance, a rock sitting on the ground will just sit there until someone kicks it or moves it. And if something is moving, it will continue to move unless something stops it.
So, if a ball is rolling on the ground, it will keep right on rolling until it hits something? Like a wall?
Exactly.
But if I roll a ball down the street, eventually it will stop all on its own.
Well, not really. Not on its own. It has a force stopping it. Gravity. Because gravity is pulling it down at the same time. Eventually, gravity's force will win out. Another way of looking at it is, say a cart is rolling down the street and suddenly hits a rock, stopping it. Only the cart is stopped by the rock. But the contents of the cart are not, and they continue to move in the direction and speed they were moving at. Again, eventually, the force of gravity will bring them down.
Wait, how does this apply to the planets?
It is only part of the story. There is the second law of motion. F equals ma, or the amount of force is equal to the mass of the object times its acceleration. Well, this is pretty straightforward. The bigger and heavier an object is, the more power it takes to move or accelerate it. It takes a lot more strength to move a boulder than a stone.
That certainly makes sense, but how does that apply to the planets?
Newton has one more law that ties it all together.
Let me guess. The third law of motion.
Very good. The third law of motion. For every action, there is an equal and opposite reaction. Think about a boat. When you row a boat, you push the oars toward the back of the boat, and this makes the boat move forward. Equal and opposite. The more power in your row, the faster forward the boat goes.
Okay, let's see if we can put all this together and see how it applies to astronomy. Using the first law, a planet that is moving through space will continue to move through space at the same speed and direction unless another force is applied. We know that the planets do not move in a straight line because they move around the sun. Therefore, there is a force making them do that. That would mean that the sun has gravity pulling on the planets?
Right. That's the only thing it can be.
But why does it move around the sun and not get sucked into it?
Well, here we can apply the second law. Notice if you throw a ball, the ball will not come straight down, but it will curve down. Since force, F, equals ma, mass times acceleration, what if we can throw the ball fast enough so that its mass times its acceleration equals the force of gravity? Would not the ball stay in orbit around the Earth?
I see. There is a force making the ball go in a straight line. It's mass times acceleration. And there is a force pulling it to Earth. Gravity. If the two are equal, the gravity will stop the ball from going straight, but not be powerful enough to pull the ball back to Earth. That's how the planets stay going around the sun. And if we apply a third law, equal and opposite reactions, then why doesn't planet's force make the sun move?
They do. Newton has modified Kepler's laws to account for this. It comes down to mass. If you have two objects of equal mass, then the balance point is exactly halfway between them. But if one is much bigger than the other, the balance point moves closer to the heavier object. This point is the center of mass. Now imagine if the mass of one object is humongous and the other very small. The center of mass is almost the center of the large object. The sun is so big compared to the planets, and the planets are so far away from the sun, that the sun moves only a minuscule amount.
This is very interesting. It got me thinking, but what if we can build a machine that can create a force more powerful than gravity on Earth? When we throw a ball into the air, it comes back down because of gravity, no? But if we can throw it hard enough with enough acceleration, then it should keep going. If this Newton guy is correct, then we should be able to do it, theoretically.
And that is how the universe stays together. Now, aren't you glad that I plunked you with that apple?
No! It was nasty of you. And just for doing that, I get twice as amount of time on the telescope tonight than you.
I'm sorry.
Too bad! Why don't you go and put those apples to good use and make an apple pie? I could go for some nice dessert. Oh, and a scoop of ice cream on top would be great too.
I can't bake.
You should have thought of that before you start throwing apples all over the place.
Check out our other episodes in the Let's Explore Astronomy series at www.tedcookproductions.com/LEA.
You will find all kinds of cool astronomy topics there.
Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.